Okay, so we know, we've talked about these quadratics a lot. It's just something of the form ax squared plus bx plus c equals 0. So that's a quadratic. We have talked about, at the beginning of the year, we did our review on factoring. Last section, we talked about graphing these quadratics. You know, if it was written in vertex form, then we could do transformations to graph them. If it was not, then we had to, if it was, you know, the standard form, then we used the formula to get the vertex. What was that formula? Opposite of b over 2a. Plug it back in, give us the y. So now we're going to look at actually solving them. In terms of the graph, when I solve this, when I find the x values that make it 0, what are those on the graph? The x-intercepts. Yeah, it's where the graph is going to hit the x-axis. You know, when we were graphing them before, we did the vertex, axis symmetry, and y-intercept. The piece we have not talked about is the x-intercept, which is what we're looking at now. To do this, we are going to focus on the zero factor property. If I could talk, that would help. And it basically says that if you have two things multiplied that equal 0, then one of those things must be 0. So what we will do is get it down to factored form. Two things multiplied with a 0 on the other side, and set each of them to 0. Key thing, guys, this only works if this number is a 0. I can't say if a times b equals 5, one of those numbers has to be 5. It only works for the 0. So let's say I ask you to solve these equations. Alright, first one. What would we have to do in order to solve that?
And x.
And subtract the 12. In order to solve these quadratics, we need them to be equal to 0. So, if I add over my x and subtract over my 12, that gives, I don't want to write in that highlighter, gives me x squared plus x minus 12 equals 0. So that's the key thing. We have to have that equal to 0 on the other side. Now, we can factor it. So if it's a 1x squared, we've talked about we can do the shortcut box method. What multiplies to negative 12 and adds to positive 1? Okay. Set each of those to equal to 0. And we get positive 3 and negative 4 for our answers. Any questions there? Remember on these, you could always check them just by plugging it back into the original and making sure that it works. You know, 3 squared is 9, 12 minus 3 is 9. 4 squared, negative 4 squared is 16, 12 minus negative 4 is 16. So you can always check this. How am I going to do B? What's different about that one? Right, I don't have a constant on this. But the setup is the same. We start by getting one side to be 0, which we have. And then we need to factor it. Now, if there's no c, how am I going to factor this? Now we have two things multiplied that equal 0, so you set each one to 0. So x equals 0, or x minus 9 equals 0. So we get 0 and positive 9 for our answers. It is possible to get an answer multiple times. In that case, we call it a multiplicity. So this is a term that we've seen before. Do you remember when we were graphing polynomials a little bit? Wait, hold on. We haven't done that here yet. Remember? No, I confused you with my college algebra class. We've not done this. So, repeated solutions are called multiplicities. So, like if I got an x plus 1 times x plus 1 equals 0. If you set each of those to 0, we get -1 twice, right? We are going to learn as we go on that while right now it maybe isn't a big deal to just say the only answer is -1, when we get into graphing higher level polynomials like the cubes and the fourths and the fifth powers, those multiplicities really have an impact on the graph. So what I want you to write is -1 m2. M represents multiplicity, and the 2. That means -1 showed up as an answer 2 times. So let's look at, yeah, you could write the x equals. So I am looking at the first one. It's a 1x squared. So we can do what? Right. Do our shortcut. Multiply to +9. Add to -6 would be a -3 and a -3. So what's my answer? 3 shows up as an answer 2 times. Okay. Looking at B. What do I need to do? Okay, so now I have it equal to 0. Why can't I do the shortcut box method here? Yeah, my A term isn't 1. So we know if it's not a 1, then we actually have to write out the box method and factor it. So no shortcuts on this one. So we put 4x squared, +9. Those multiply to a +36, and I need things to add to a -12. What did you say the numbers were? Okay. Then if we factor 4x squared and -6x, we could take out 2x. -6x and +9. 4x squared and -6x. 2x and -6x and +9 would be -3. So we get a 2x minus 3. You can write it twice. You could also just write it as squared either way. So now it's equal to 0, so we would just set each of those equal to 0. They're identical, so really I just need to solve one. So if you add your 3, divide by 2, x is 3/2. And then what would I need to put with that? M2. It really showed up twice. All of these quadratics should be getting 2 answers. So whether it's two different ones, or if you have an M2 on the end.
If it's different ones, we don't need to mind the M2.
Right. Because they would each only be an answer one time. Questions there? So this is solving by factoring. We've also talked last year about the square root method for solving. Let's look at this one. I could set this equal to 0 and factor, and that would be fine. But we're really just trying to solve for x. And how many x's do I have in my problem? Yeah, I just had that one x squared term, right? So there's two x's, but it's only in one term. Could you just get the x by itself?
I shouldn't.
Yeah. If I just wanted to get this x by itself, I could square root. Now, if you add a square root, what else do you add? Okay, so I have x equals square root of 5 does not reduce, so x equals plus or minus radical of 5. Now, if it had been like x squared equals 5x, could you have just done the square root? No, because there are x's in more than one place. The only reason we were able to just square root is because in the original problem I just had a single term with an x in it, so I could just get that x by itself. Looking at the next one. If I needed to get this, or I want to solve this for x, what are your thoughts? There are two different approaches. Okay, one option would be to divide our 3 over. So those drop, so I get x minus 2 squared equals 16. And then what would we do?
You take the square root to get rid of your 2 power.
Yes. There's only an x in one place, so we can just solve for it. So if I square root, when you add a square root, you need plus and minus. So we get x minus 2 equals plus and minus. The square root of 16 is 4. Okay. Here's where you need to be careful. If I add my 2 over, your answer is not plus or minus 6. Okay, that's what people want to do. They want to just add those like terms, but this is incorrect. What this means is if I add my 2,
Don't you have to like subtract the back?
yes,
Subtract 1 and add 1.
yes. This means 2 plus or minus 4. So you have to do 2 plus 4 and 2 minus 4. So we actually get x to be positive 6 or negative 2. So be careful with that plus and minus when you go to add over your term. Does that make sense over there? Yes, ma'am.
On E, you said that what would happen if there was an x on 5?
You would have to subtract
5 and then...
the 5x over and then pull out your x. Other questions? I'm going to put a couple up for you guys to try. So first one, you add your square root plus and minus. So x minus 1 equals plus or minus the square root of 4 is 2. Add your 1 over. So 1 plus 2 is 3. 1 minus 2 is negative 1. So 3 and negative 1. This one, square root with it plus and minus. What's the square root of negative 49? Alright, good. Those okay with everybody? I'm going to throw one more up here. There's a question like this on the Math Excel. So it says find A, B, and C for the quadratic equation with solutions x equals 8 and x equals -4. Alright. So this one is kind of working backwards. I've given you the solutions, you have to find the original equation. If 8 is a solution, then what showed up in my factored form? X minus 8. If -4 is a solution, what was in my factored form? X plus 4. And this equals 0. That's how we got our answers. Okay, so from here, I'm asking you about the original quadratic. I want the A, B, and C, so what do I need to do? FOIL it out. So we get x squared plus 4x minus 8x minus 32. So x squared minus 4x minus 32 is 0. So my A is 1, B is, and C. So you might have to work backwards, just being able to look at the solution and write the factored form from that. What I want to do, this is pretty much where I'm going to stop today, but I do want you to write one thing down in your notes so we can pick up there tomorrow. So tomorrow we're going to talk about completing the square. What I want you to do, this next slide is kind of wordy. I would like for you to write this down so we can pick up here tomorrow. And then there is a Math Excel assignment. What I have done for this section, we're going to spend a little bit of time on it. I have broken it up into daily assignments, so there is a Math Excel covering just what we talked about today that is due by the end of the day tomorrow. So once you get this written down, then you can start that Math Excel, and it is due tomorrow.